Okay, so we've talked about how to solve a two variable system of equation using substitution and elimination. Today is going to be applying those concepts to solve application questions. And so for the notes today, I'm going to go through an example in a minute, but I just want to go through some general tips on how to approach these questions. Okay, number one is clearly label a diagram if, I'll say, applicable. So some of these questions you won't be able to do this, but if you can, it's really important to label a diagram. Number two is expect these to be more challenging, especially compared to the last two lessons, which I think weren't too bad. These are going to be a little bit more challenging because setting the question up is going to be can be pretty difficult. Number three is see if a problem is patterned or modeled after a problem you've seen before. Okay, the best way I think you guys are going to get good at these types of questions is just by doing a lot of questions so you can get an idea of how you can kind of think about setting up the equations. And then for some problems, involving distance, rate, and time, there's three formulas that you might see. The distance of something is equal to the rate times the time, which means the rate of something is equal to the distance over time. These are all related to each other. And so the t value, the time, is equal to the distance over the rate. And these are three relationships that you're going to see, especially when these application questions involve finding the rate or distance of something. Okay, and we're going to see a couple questions that have that. All right, so for example, let's go through a practice question. We have a Boeing 747 jet that flies 7 hours west with a 60-mile-per-hour tailwind. 4 hours west with a 60-mile-per-hour tailwind. So what that will look like is this. It's going this way, west, for 4 hours. And then there's a tailwind. It's going 60 miles per hour. And so the rate at which this plane is flying is r plus this tailwind. So imagine a plane's going like 500 miles per hour. If the tailwind is 60 miles per hour, the plane's actually going to be going 560 miles per hour. Okay? Returning against the wind takes 5 hours. So this time it's going into the wind. So 5 hours. 60 miles per hour. And so the rate at which it's going into the wind is going to be r minus 60. It's going to be going slower. So this is with tailwind over here. And this over here in green is into headwind. Okay, so how do we solve a question like this? The idea is we want to solve for r. That's going to be the speed of the jet with no wind. The distance the jet has traveled is equal to the rate at which it's traveling times time. Okay, and there's actually two equations we're going to set up here. Let's start with the first scenario. The distance this plane is traveling is equal to the rate. Well, we're going to call the rate r plus 60 because it's we're adding the miles per hour of the tailwind to the rate of the plane times t. And then the second equation, the distance is equal to the rate minus 60 times t. Okay, so we know what the t values are, and we're going to use that to set up two equations. The distance here is equal to r plus 60 times t for the first scenario, which is 4. And the second equation is d is equal to r minus 60 times 5. Because that's the time in the second scenario when it's going into the headwind. And so now we have a 2 by 2 system of equations, two equations with two unknowns, and we're going to use those principles that we learned the last two lessons to solve this for r. Okay, we could solve this for d if we wanted to, but we actually don't need to. And I think the easiest way to solve this for r is treat this as a substitution question, and we're just going to set them equal to each other, and that will eliminate the variable d. So we have r plus 60 times 4 is equal to r minus 60 times 5. Now let's solve this for r. So 4 times r plus 240 is equal to 5 times r minus 300. Well, we can move the 300 to the left-hand side and the 4r to the right-hand side. Let's move the 300 first. And now we can move the 4r over. So r is going to be equal to 540 miles per hour. Okay, and that's the rate at which the plane is traveling. Okay, I think the hardest part about these questions is setting them up. So recognizing this system of equations here. That is going to be the trickiest part, because once you do that, it's just a 2 by 2 system of equations, which you guys know how to do based on the problems we went through the last two lessons. Practice. Okay, let's say we have two types of antifreeze mixtures. One is called steady state, and it has 18% alcohol. The other one is called even flow, which has 10% alcohol. How many liters of each should be mixed to get 20 liters of mixture that is 15% alcohol? So this is a pretty common question you're going to see. They like to ask these types of questions on the SAT. Let's start by recognizing a couple things. One is, we'll call L1 the total amount of steady state solution. So L1 will be steady state. State. L2 is going to be the even flow. L because it's going to be in liters. So it's the amount of steady state. Okay, so equation number 1. If I have two of these mixtures and I'm putting them together, the total amount is going to be 20, which means that the total amount of liters of steady state, L1, plus the total amount of even flow, L2, is going to be equal to 20 liters. That's our first equation. So the total amount of one solution plus the total amount of the other solution is going to be equal to 20. Okay, that one I hope isn't too bad. It just comes from the fact that we want to get 20 liters total at the end. The second equation is a little bit more challenging. Okay, so on the right hand, let's start with the right hand side. We want the mixture to be 15% alcohol, so let's write this as a decimal, 0.15. We're going to multiply this by the total amount of volume once we've mixed these solutions together. And that is going to be L1 plus L2. Okay. On the left-hand side, we want the total steady-state alcohol plus the total even flow alcohol. So the total steady-state alcohol is the alcohol percentage times the volume of the steady-state solution. So this is the total steady-state alcohol. And we're going to add to this 0.1, 10, times the total amount of volume of the even flow solution. And this right here is the total even flow alcohol. This is the hardest part about this question, setting this equation up. So if I have the total amount of alcohol from the first solution and I add to it the total amount of alcohol from the second solution, the result is going to be, well, we want the result to be 15% of the sum of the two volumes, okay? And what we want to do here is solve this for L1 and L2. So here's our first equation up here, and our second equation is down here. Okay, now to solve this, let's do a couple things. One is, well, the first thing we can do is just recognize this over here is going to be equal to 20. That'll make the algebra a little bit easier. So we're going to replace L1 plus L2 with 20. Let's do a substitution method. So I'm going to solve the first equation for L2 by subtracting L1. And then we're going to substitute this expression into the second equation for L2. Now let's solve this for L1. So 0.18 L1 plus, we're going to distribute the 10 to both these terms. Well, this is 2 minus 0.1 L1. 0.15 times 20 is going to be 3. And now let's do a little bit of math here. So 0.08 L1 is equal to 1. And I'm going to divide by 0.08. And if I do that, the L1 value is 12.5 liters. Okay, which tells us that this is the steady state amount. And then the even flow amount is going to come from plugging, we could plug this in right here. So this becomes 20 minus 12.5, which is 7.5 liters even flow. All right. We're going to go through two more examples. One of them is going to be a little bit easier, and the other one's going to be a little bit more challenging. Okay, so problem set number 1, we have a museum that charges $12.50 for youth or children, and then $17.50 for adults. We know that on Friday the museum collected a total of $1,535, and we know that the total number of youths and adults together is 110. All right, and so let's start by just denoting a couple of things. We're going to call letter A the number of youths. I'm just going to say children. And then letter B is going to be the number of adults. Okay, so we know that the sum of these two values, the total number of youth and adult, or children and adults, is 110. 110. If the total amount of money from the museum is $1,535, then the total amount of money from children is going to be the price per child times the number of children, plus and for adults, it's going to be the price per adult times the number of adults. So this right here is the total amount of money made from children who have entered the museum. And then this over here is the total amount of money made from the adults who've entered the museum. If we take the sum of these two values together, we know that the total amount of profit is $1,535. Okay, we're going to use this as a system of equation now to solve for A and B. We'll call this equation 1, and this right here will be equation 2. Okay, so let's solve this with we could do a couple of different things. I think a method of substitution is going to be the easiest. So I'm going to take the first equation here and solve it for B. And then let's substitute that into the equation, second equation. So instead of writing B, we're going to write 110 minus A equals, I'm just going to get rid of the dollar sign, 1535. Well, let's distribute the 1750 to both these terms. So 1250A plus 1925 minus 1750A is equal to 1535. Okay. Well, if we combine the like terms here on the left-hand side, this becomes minus 5. And then if we subtract 1925 on both sides, this becomes 900, or minus 390. So the value of A in this problem is 78. If we know the value of A, we can quickly find the value of B by plugging A into this equation here. And so the B value is going to be 110 minus 78, which is 32. All right, let's wrap up this question, or this video, by going through a more challenging problem. Okay, Grady's station wagon gets 18 miles per gallon in a city driving, and then 24 miles per gallon on the highway. If the car is driven 465 miles on 23 gallons of gasoline, how many miles were driven in the city, and then how many miles were driven in the highway? Okay. Hardest thing is going to be setting this up properly. So we know the city is 18 miles per gallon. Okay, let's call this M1 over G1. Miles over gallons is going to be 18. And then the highway is 24 miles per gallon, and that's going to be equal to M2 over G2. So let's set up two equations that model this scenario. Equation number 1. The total amount of miles in the city plus the total amount of miles on the highway is equal to 465. So M1 is the miles driven in the city, M2 is the miles driven in the highway. We know that the sum of those two values is going to be 465. Secondly, we know that the sum of the amount of gasoline used, we'll call this G1 plus G2, is equal to 23. Okay, but what we want to do is we want to have these two equations represented in terms of the same two variables, in this case M1 and M2. And so what I'm going to do is we're going to take these equations here on the left-hand side, these relationships, and I'm going to solve these for G1 and G2. So G1 is going to be equal to, if we multiply both sides by G1 and then divide by 18, M1 over 18, and then G2 is going to be M2 over 24. And we're going to plug these values into the second equation. So instead of G1, we're going to write M1 over 18. And then instead of G2, we're going to write M2 over 24 equals 23. So we're going to use this as our first equation, and then this will be used as our second equation because they have the same variables. I think a method of substitution will be the easiest method to use here. Let me just rewrite these two equations down here. So we want to solve this system of equations, and then that will be it for this video. So here's our first equation, and then here's our second equation. So let's take the first equation and solve for m2. 465 minus m. So subtracted m1 on both sides. If we do that, we can rewrite the second equation as m1 over 18 plus 465 minus m1 over 24 equals 23. Okay, to solve for m1, there's a few different ways we can approach this. I'm going to multiply by 24. I'm going to multiply the entire equation by 24. If we do that, we get 24 m1 over 18 plus, well, the 24s will cancel, 465 minus m1, and then 23 times 24 is 552. Well, this becomes 4m1 over 3. 24 over 18 is the same thing as 4/3. Minus m1 plus 465 equals 552. And let's subtract these together and then subtract 465 on both sides. So we end up with 4m1 over 3 minus 3m1 over 3 equals 87. So we end up with m1 over 3 equals 87. And so the m1 value in this case is 261 miles. If we know that the total amount of miles driven is 465, this relationship here, m1 plus m2 is 465. We know 261 plus m2 is equal to 465. And the last thing we're going to do to get our final answer is just subtract 261. So this is 204. So the total amount of miles driven in the city, 261 miles. Total amount of miles driven on the highway is 204. And that is it for this video.